Hello guys. So today we are going to discuss about the presence of digital circuits in magnetic resonance imaging MRI mission. So talking about digital circuits, first you need to know what are digital circuits. Digital circuits are nothing but they are electronic circuits that operate on digital signals which have discrete values representing two states. One is 0 and 1. 0 represents off condition and 1 represents on condition. These circuits are the foundation of modern electronics, found in everything from simple calculators to complex computer processors. They are built using components like logic gates, flip flops, and registers to perform specific functions such as arithmetic operations, data storage, and control tasks. So, this is a brief introduction about digital circuits. So, next, let's look into the introduction part of MRI mission. Yeah. Magnetic resonance imaging MRI is a non-invasive medical imaging technique that uses strong magnetic fields and radio waves to generate detailed images of the internal structures of the body. It's particularly useful for examining soft tissues like the brain, muscles, and organs, providing valuable insights for diagnosis and treatment planning without the use of ionizing radiation. So, this magnetic resonance imaging MRI system, it's a non-invasive medical imaging technique. So it gives the exact image of an internal organ which is damaged or repaired. So internally in our body, certain organs or body parts get affected, and those body parts generate detailed images of the internal structures of the body. So it's particularly useful for examining soft tissues like the brain, muscles, and organs, providing valuable insights for diagnosis and treatment planning without the use of ionizing radiation. So here there is no need of using this harmful ionizing radiation. So this is a brief introduction about MRI system, magnetic resonance imaging system. So next, let's look into the basic MRI hardware. So firstly, talking about this basic MRI hardware, the first thing is magnet. Magnet, large magnetic field that is homogeneous over a large area, aligns protons in the body. Radio frequency RF coils. So radio frequency RF coils, talking about radio frequency RF coils, these coils transmit and receive RF energy into and from the body. Gradients induce linear change in magnetic field, spatial encoding. And also we have computer system and console, then patient handling system. Then all MRI scanners include several essential components. First, in order to create net nuclear spin magnetization in the subject to be scanned, a polarizing magnetic field is required. This main magnetic field is generally constant in time and space and may be provided by a variety of magnets. Once net nuclear spin magnetization is present, this magnetization may be manipulated by applying a variety of secondary magnetic fields with specific time and or spatial dependence. These may generally be classified into gradients, which introduce defined spatial variations in the polarizing magnetic field, that is B0, and radio frequency RF irradiation, which provides the B1 magnetic field needed to generate observable transverse nuclear spin magnetization. B0 gradients are generally created by applying an electric current supplied by gradient amplifiers to a set of electromagnetic coil windings within the main magnetic field. So, firstly, there is a need of this strong magnetic field as we discussed before, and also this mission uses radio waves. So there is one main magnetic field, and around that surrounding we have this other magnetic fields such as B0 and B1. So these are gradients, and they are intertwined by a set of electromagnetic coil windings within the main magnetic field. So next, so these are the basic MRI hardware. And next we have RF radiation. RF radiation is applied to the subject by one or more antennas or transmitter coils connected by a set of synthesizers, attenuators, and amplifiers known collectively as a transmitter. So, transmitter is created together by a set of synthesizers, attenuators, and amplifiers. So, with the influence of the main magnetic field, the field gradients, and RF irradiation, nuclear spins within the subject induce a weak RF signal in one or more receiver coils, which is then amplified, filtered, and digitized by the receiver. So, the receiver makes this weak RF signal amplify, filter, and digitize. Finally, the digitized signal is displayed and processed by the scanner's host computer. So you have this scanner's host computer. So in the scanner's host computer, you get this digitized signal. First, the weak RF signal gets amplified. After several amplifications, filtrations, and digitization, you get this final output from the receiver and it is projected on the scanner's host computer. So, this is all about the basic MRI hardware. Next, the main block diagram. Talking about MRI system block diagram. So, as you can look in this picture, the patient is laid down in the bed and there is this main magnet, an RF coil, and below that, gradient coils. An RF amp, X amp, Y amp, Z amp are nothing but amplifiers. And we have spectrometer. Spectrometer, talking about spectrometer, it measures the wavelength of electromagnetic radiation, that is light. So it is used to measure the wavelength of electromagnetic radiation. And these amplifiers all they amplify the weak signals and filter one by one and then project the final output. Then gradient coils are loops of wires or thin conductive sheets on a cylindrical shell lying just inside the bore of an MRI scanner. So this is the big bore of an MRI scanner. So it lies inside this big bore. These radiant coils rise inside this big bore. So this is all about the main block diagram of MRI system. Next, MRI scanner components. We have MRI scanner components. There is this RF coils, gradient coils, and main magnet, and they have amplifiers XYZ, RF electronics, then gradient amplifiers, and pulse sequence computer, then image reconstruction computer. These are all control electronics. And last, we have separately one host computer, that is scanner host computer console connected to image reconstruction computer. Okay, so as a scanner components, these all play a major role. Now, under the hood of an MRI scanner, you can see in this picture clearly, you have styrostat, gradients, body RF coil, and passive shims. These passive shims, what it does is that this helps the patient to go inside and it gives the whole image of the individual, the image of an whole individual. You can look here. The RF coils, gradient coils, main magnet are connected one by one, and amplifiers are connected, and electronics connected. So in these electronics, digital circuits play a huge role. So digital circuits, without these digital circuits presence, you can't run a mission. You can't run an electronic mission. In that way, digital circuits help this MRI scanner. So that's all about digital circuits and magnetic resonance imaging MRI. So, thank you.